Hello everybody, in this video I will teach you all about the laws of exponents. We will be dealing with when there's multiplication, division, and I will also teach you why anything to the power of 0 is equal to 1. Let's start with the terminology. When I give you this, the whole thing is referred to as the power. The 6 in front of the variable is called the coefficient. The x is called the base of the exponent. And the little 3 on top there is called the exponent or the index. Then I just want to explain to you, index is singular and indices, they are plural. We will start with law 1 that deals with the multiplication of exponents. Now the law says when the bases are the same and we multiply, we add exponents. Simplify the following. Let's do a few examples. On number 1, the first thing that we will deal with will be the coefficients, and this is just normal numbers, and you will say 2 times 5 is 10. And then in terms of the bases, since it's multiplication, the bases are the same, we add exponents, and therefore it's a to the 4 plus 3, and the final answer 10, a to the 7. With example 2, we will say the coefficients 4 times 10 is 40, and then in terms of the base a, we add exponents 4 plus 6, and then b, the exponents, we will add them 3 plus 7, and the final answer 40, a to the 10, b to the 10. On example 3, the only thing that's different here is suddenly it's minus 5 times minus 4. You deal with them in the normal way, so it will become plus 20, and then in terms of the base x, the exponent is 3, and suddenly there's a 1. So where does the 1 come from? When you go to minus 4xy, remember if there's no exponent, there is an invisible 1. That's why in terms of x, it becomes x to the 3 plus 1, and y, the exponents, you will add 2 plus 1. And your final answer, plus 20, x to the 4, y to the 3. There's the law. Let's do more examples. Number 4. So for this one, suddenly you find a 7 squared and a 7 cubed. Now it's still multiplication, the base is 7, so you will still just add exponents, and it becomes 7 to the power 2 plus 3. In terms of p, you find a 4 as the exponent, you find a 6, so it will be p to the power 4 plus 6. And in terms of q, there's a 3 and a 2, so you will say q to the power 3 plus 2. And then your final answer, 7 to the 5, p to the 10, q to the 5. Example 5. Now suddenly your base is x, and there's multiplication. So now it doesn't matter that your exponents are not numbers, they are variables, and we know how to deal with them. So this one will be x to the power n plus 2n, which is x to the power 3n. And then number 6, here the base is 5. It's multiplication right through, so we will just use the law where we will add exponents. Just remember, on 5, if there's no exponent, there is an invisible 1. Don't forget about that one. So now you will apply the law and you will say the base represented is 5, and we add exponents. X plus 2x plus 1, which becomes 5 to the 3x plus 1. The second law deals with division of exponents. And this one says when you divide exponents, you subtract them. Now it works like this. I tell my students, and you are one of them now, this A will go and stand directly on top of that one, and then it's always the top one, x minus the bottom one. Let's do some examples. The questions simplify the following. Number 1, you find 7 to the 5 divided by 7 squared. So now this 7 will stand on top of that one, and it becomes 7 to the power 5 minus 2, and which is 7 cubed, and if you work that out, if you want to, 343. Example 2. So now with the 16 divided by negative 4, you deal with it exactly the same way as all the other times. So you will say a plus divided by a minus is a minus, and then 4 goes in itself once and 4 goes in itself 4 times. So that's for your coefficient in front. In terms of A, this A will go and stand on top of that one, and we subtract, and it's always the top one minus the bottom one. So it's A to the 4 minus 2. In terms of B, it's B to the 8 minus 5. And in terms of C, remember, if there's no exponent, there's an invisible one. So it becomes 3 to the power, C to the power 3 minus 1. And then when you work it out, it's negative 4, A squared, B to the 3, C squared. Let's do another example. There's your law, the questions simplify, and then example 3. So now we will say a minus divided by a minus is a plus. And then in terms of the coefficients, it's 5 goes in itself once, 5 goes into 25, 5. And then in terms of P, it's division. So we will say P to the power 7 minus 3, Q to the power 4 minus 2, and then there's no other thing that you can do with R, so R writes with. And then can you see there's the 5 under the line, and the whole expression is positive. And then your final answer will be positive P to the 4 Q squared R over 5. Example 4. So now the base is x and it's division. So what we will do is the x will go and stand on top of that one, and then we will subtract. Now have a look at this one. What you do is, since there's 2 terms under the line, you write a minus and then a bracket in plus 4, so that in the next step you can multiply in the minus, and it becomes x to the n plus 5 minus n minus 4. And then you can say n minus n is nothing, and plus 5 minus 4 is 1. And therefore your answer, x to the 1. And you don't even have to write this one. You can just write x. Law 3 deals with the zero exponents. Now it works like this. Anything to the 0 is equal to 1. So now you might say, but why? Let me explain. When I give you the sum a to the 4 divided by a to the 4, if you do this sum and we say we write it in expanded notation, then a to the 4 is the same as a times a times a, etc., divided by a times a times a times 8. Then you can say a goes in itself once, a goes in itself once, a goes in itself once, a goes in itself once. You catch my drift here. And then you will be left with 1 over 1, which is 1. So now we end it with the 1. When we do the same sum, a to the 4 divided by a to the 4, and we use use the laws of exponents. We end with a to the 4 minus 4, which is 0, a to the 0. So do you agree? There's your proof that anything to the power of 0 is equal to 1. Now let's do a few examples. Simplify the following. So on number 1, you find 3y to the 0. Remember, if there's nothing there, there's an invisible times. So in fact, it's only the y to the 0 part that's equal to 1. You still have the coefficient 3 in front. So then you will say 3 times 1 is 3. The next example, now it's 3y inside a bracket, the whole thing raised to the power of 0. And now you can say the answer is 1. Everything raised to the power of 0, 1. On this example, there is a minus in front, and then you find a 7 to the 0. So it's only the 7 to the 0 that's equal to 1, and the minus writes with. And then on example 4, now you find minus 7, the whole thing inside a bracket raised to the power of 0, and the answer there is 1. In the next video, I will teach you how to raise a power to another power. Click on the video in the left-hand corner to take you straight to the next lesson.